everyone, welcome back to Algebra 2. Today we are on page 318 of your workbook and we're going to be looking at 6-7 geometric sequences. Now what is a geometric sequence? A geometric sequence is a sequence form where there's a constant ratio between consecutive terms. So here's what I'm talking about. Let's say I had the sequence 3, 6, 12, 24. That's supposed to be a 24. And so on. I would check to see if this were a geometric sequence. If to get the term after, then I would need to multiply by the same number between terms. So to get from 3 to 6, I could multiply 3 by 2 and get 6. To get from 6 to 12, I can multiply 6 times 2 and get 12. To get from 12 to 24, we can multiply by 2 again. So that's what would make this a geometric sequence, the 3, 6, 12, 24, because the number that you're multiplying each term by remains constant. So we would call the 2 that we're multiplying, we would call that our R, or the common ratio. So we have a couple of examples right here, and we're actually going to change example 1a. We're going to mark this off. And we're going to start off with something else, like let's make this 5, negative 25, positive 125, and then the next term would be negative 625. And then we'd go continue on. Okay, so we have to determine, is the sequence geometric? Well, it's geometric if I multiply by the same number, by a constant number for every term. So is it geometric? Well, let's see. 5 times negative 5 is 25. Negative 25 times negative 5 is 125. And 125 times negative 5 is also negative 625. And these are little x's times. So our R, our common ratio, would be negative 5. Now they ask us to do something. They ask us to write a recursive definition for the sequence. So let's go find out what the recursive definition is. I have it written down here. We'll zoom in on it. The recursive formula, you want to pause the video and write it down. The recursive formula really just tells you how the formula works. There's 2 lines. It looks like a piecewise function, but we'll start off with an, which means the number of the term that you want. And A1 stands for the first term. So it defines the first term. So it's okay, my first term is A1 if n is 1 and n is the number of the term. The second line tells you how you would get the next term. So you would take A sub n minus 1, which is the previous term, and multiply it by the common ratio if n is greater than 1. So whenever you see a recursive formula, there will be a number substituted in for the A sub 1. You'll substitute a number for this, and you'll substitute a number in for the R. So let's try to practice writing a recursive definition up here on example 1a. And then what helps whenever we're working with formulas, if we keep writing them down, that way we get more comfortable with all the parts. So here's the formula. It's A sub n equals A1 if n is equal to 1, and then A subscript n minus 1 times R if n is greater than 1. So to write the recursive formula, I need to fill in this number and this number, and everything else will stay the same. So that means I need to go to my sequence. We already determined that R equals negative 5 because we multiplied by negative 5 to get to each term. Now I need to figure out what my first term is, A sub 1. That's the very first number that you're given in the sequence. So my first term is 5. So when I go to write my formula for the recursive definition, it's going to be 5 if n equals 1, And then my second line, a sub n minus 1 times the common ratio -5 if n is greater than 1. The way that I like to think about the recursive formula is how it works. So the first line tells you what you start with. So my first term, n equals 1 means that's your first term. So my first term is 5. The sequence starts with 5. This a sub n minus 1, that's your previous term. And then -5 is the r, which you multiply by to get all the other terms. So what the second line is saying is to get every other term other than the first one, we're going to take the previous term and we're going to multiply it by r. So let's go backwards from that. Let's say I'm going to change example B now. I had the recursive definition a sub n equals the piecewise function -3 if n equals 1, and then a sub n minus 1 times -1 if n is greater than 1. I just made that up. Let's say this is the recursive definition. What are the numbers that go in the sequence? Well, I'm told that if n equals 1, which would mean the first term, my first term is -3. So I know my first term, -3. Then it says to get the second line, this line right here says to get every term after that, you take the term before it and multiply it by -1. So -3 times -1 is +1. 1 times -1 is, -3 times -1 is not +1. -3 times -1 is +3. Then to get the third term, I take the previous term, 3, multiply it by -1, -3, and so on. That's how the recursive definition works. The next thing you'll have to do is you'll have to look at the recursive definition and change that to the explicit definition for a sequence. Because while the recursive definition is nice for telling us how the sequence works, it's not so great for solving problems. So we have our recursive formula with all the defined terms. Now we have our explicit formula. A1 still means the first term. R is the common ratio. N is the number of the term that you want. So we use the recursive form to define the formula. Well, maybe not the formula, to define the sequence. And we use the explicit formula to solve problems. Okay, so here on example 2, we've given the recursive definition. We want to know what's the explicit definition. Well, the recursive definition says that my first term is 12, so it starts off 12. Then every term after that, I take the previous term. So in this case, to get the second term, I would take the first term and multiply it by a third. So 12 times 1/3 would be 4. 4 times 1/3 would be 4/3. 4 times 4/3 times 1/3 would be 4/9, and so on. What's the explicit definition for the sequence? Well, according to my notes, the explicit formula is a sub n equals A1 times R to the n minus 1. So I need to know what A1, R, and N are. When I write the explicit definition, I only need to substitute a number in for the A1 and for the R. So my explicit definition, A sub n, my first term is 12. R, what are we multiplying by? R is the 1/3, so 1/3 to the n minus 1. Now we're going to use our geometric sequences to solve problems. So in example 3, we see that a geometric sequence can be used to describe the growth of bacteria in an experiment. On the first day of the experiment, there were 9 bacteria in the Petri dish. On the 10th day, there were 3 to the 20th bacteria in the dish. How many bacteria were there on the 7th day of the experiment? So I've underlined a couple of items that we've been given. I know that on the first day there were 9 bacteria. On the second day, I don't know, third day, fourth, fifth, sixth, seventh day is what I'm trying to figure out. 8th, 9th. On the 10th day, I know there were 3 to the 20th bacteria. Now I could kind of work backwards and try to figure out what 9 would have to be multiplied by this many times to end up with 3 to the 20th. Or I can use my explicit definition to solve. So the explicit definition is AN equals A1 times R to the n minus 1. And I can look at the information I have and I'm going to substitute what I know. Right now I know initially there's 9 bacteria, so that tells me that A1 equals 9. So now my formula looks like this. A sub n equals 9 times R to the n minus 1. Okay, well now I don't know R and I don't know N. So in order to figure those out, I'm going to use this information. On the 10th day, there were 3 to the 20th bacteria. So the 10th day would be the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be my 10th term. So this is telling me that A sub 10 equals 3 to the 20. Or another way to say that is when n equals, n being the number of the term, when n equals 10, the term is 3 to the 20th. This information is going to help me decide what R is. So I'm going to take my formula and I'm going to figure out what my common ratio is. So I know that A sub 10 and I'll keep the 9. R is what I'm trying to solve for. That will be 10 minus 1. I also know that A sub 10 is 3 to the 20th. So 3 to the 20th equals 9 times R to the n minus 1. And here I have a nice little exponential equation. To solve this, I can divide both sides by 9. So I'm going to pull my Desmos calculator over here and help me solve it. To solve my exponential equation, I need to isolate the exponential part first. So I'm going to take the 3 to the 20th and I'm going to divide it by 9. So now I know that that number, 3 0.87420,489 equals r to the n minus 1. Now to get and we're not going to do habits of mind, so we can take this out. To get the x out of the exponent, I can rewrite in log form. Just kidding. I don't need to rewrite it in log form because I know that on the 10th day, n is 10. So my n value right here should be a 10. And 10 minus 1 is 9. So now I have 38720,489 equals r to the 9th. So then if I wanted to get r, I'll take the 9th root of both sides, or raise to the 1/9 power. And r is, let's see, let's do it to the 1/9 power. 38720,489 to the 1/9. It's missing a 4 there. So when I raise it to the 1/9, I get r equals 9. Now that's not answering my question, but it does give me a number to substitute into my r value. So now I can take my equation and I can say that a sub n, now that I know r, equals 9 times r, which is 9, to the n minus 1. That's going to allow me to finally answer this question. How many bacteria were there in the dish on the 7th day of the experiment? So that's asking me, what is a sub 7? Which means I'm going to substitute 7 in for n. So a sub 7 is going to be 9 times 9 to the 7 minus 1. I'll grab my calculator. Scroll down. 9 times 9 to the 6th power. And we see that a sub 7 equals 4782969 bacteria. So if you need to solve for some unknown value, if they ask something like, how many were there on the 7th day? Or what's the third term? You're going to want to use the explicit formula, substitute in the values you know, and solve for what you need. Sometimes they'll give you a specific term, then you have to use that to solve for r. Sometimes you can just go straight through. All right, now let's move on to example 5. Find the number of terms in a series. Now, we're switching from the word sequence to the word series. So here's what a series is. Series is when we take a sequence and we start to add up all those numbers. So let's say I had the sequence again, 3, 6, 12, 24. Before there were commas in between the terms. Now we're going to put plus signs in between those terms and add them all up. The sum of all that would be a geometric series. There is a formula for the sum of a geometric series, for the first few terms of a geometric series. It's S sub n. The S stands for sum of a1 times 1 minus r to the n over 1 minus r. The r stands for the common ratio. The a1 is still the first term, and n is the number of the terms that you want. So you'll have something like example 5 where it says, well, how many terms are there? So we have our series and we have to figure out, okay, well, it went from 3, 6, 12, it skipped a few and got to 768. They want to know, okay, well, how many did we skip? So how many are there altogether? one way you can do this is to start with that sum formula. So I'm going to start with the formula. I'm going to fill in what I know and see if I have enough information to finish it up. S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Let's see what we know. Well, let's see. I know the first term is 3, so there's a1. All right, I'm going to highlight that I know a1. To get from 3 to 6 and 6 to 12, we had to multiply by 2. So that tells me r equals 2. All right, so I know r. But I don't know how many terms there are in the series. So maybe instead of using the sum formula, because there's two unknowns, maybe I'll try using my geometric formula. A sub n equals a1 times r to the n minus 1. I know a1, I know r. I don't know n, but I do know that my last term is 768. So we're going to say that this is a sub n. So I can say that 768 equals my first term 3 times my common ratio 2 to the n minus 1. Now I have an exponential equation that I'm trying to solve. To solve an exponential equation, first of all, you need to isolate the exponential expression, which is the number that has the exponent. So I'm going to need to divide both sides by 3. 768 divided by 3 is 768 divided by 3 is 256. So now I know 256 equals 2 to the n minus 1. I'm solving for n, so what I can do is I can rewrite this in log form. I can say this is log base 2 of 256 equals n minus 1. To get the n by itself, I can add 1 to both sides. So if I add 1 here, add 1 there, have 1 plus log base 2 of 256 equals n. I'll type that into my calculator. One plus log base 2 of 256. It's 9. So how many terms are there in the series? There's 9. 9 terms. Part B gives me the sum. It tells me the first term, and then it tells me the common ratio, and it wants to know how many terms are there in the series. So since this one gives me the sum, then maybe I'm going to try using that sum formula again. S sub n equals a1 times 1 minus r to the n over 1 minus r. Okay, do we know a sub 1, the first term is 5? Yes, I do. It also tells me the sum is 155. So I'm going to start 155. Tells me the first term is 5 times 1 minus, common ratio is 2, to the n, which is what we're trying to solve for, over 1 minus 2. Another exponential equation. Before we convert to log form, we want to simplify as much as possible. So 155 equals 5 times 1 minus 2 to the n. 1 minus 2 is negative 1. I can multiply both sides by negative 1. 5 times 1 minus 2 to the n. Then I can divide everything by 5. So negative 31. Just going to double check myself. 155 divided by 5, rather negative 155 divided by 5 is negative 31, equals 1 minus 2 to the n. Subtract the 1 on both sides, negative 32 equals negative 2 to the n. And I'm not quite ready to take the log of both sides because I got to get a positive number here, so I'm going to divide everything by negative 1. So that I have positive 32 equals 2 to the n. To solve for the n, I can rewrite in log form. Log base 2 of 32 equals n. Type that into your calculator and you'll know how many terms there are in the series. Next, we need to talk about the sum of a geometric series, or rather the summation notation. You'll see a symbol that looks like this, and we've seen this earlier in the year. It means the sum. And just a reminder, this sum means I'm going to take the formula 1/2 times 3 to the n minus 1, and I'm going to start substituting in numbers. I'm going to start at 1. I'm going to stop at 5. So this would look like 1/2 times 3. I'm going to start at 1, so I put 1 up here, minus 1. Plus, I'm going to take that formula again, 1/2 times 3, and then I go up to the next integer, 2 minus 1. Plus 1/2 times 3 to the 3 minus 1. Plus, my watch is getting in the way. Plus 1/2 times 3 to the 4 minus 1. Plus 1/2 times 3 to the 5 minus 1. And now I can stop because I have gone from n equals 1 to 5. So I took this formula and I replaced the n with a 1 and then a 2 and then a 3 and then a 4 and then a 5. And then I would evaluate that by evaluating each term and adding it all up. But that could take forever. So instead, we've got a calculator we can use where I would go to Desmos. I'm going to find the sum. You can go into the functions button, or you can just type the word sum, and it'll start off. We're going to go from n equals 1 to 5. Whoa, not sub 5. N equals 1 to 5. And then I just type in my formula. You're going to need to use parentheses around the whole thing, though. 1/2 times 3. Oh, I don't want the 3 up there. Times 3 to the n minus 1. I'm putting parentheses around the exponent so it all stays in there. Close parentheses. And then it'll tell me it's 60.5. Lastly, the last thing we're going to need to do is we are going to need to scroll down here, to do something like calculating a monthly payment. So let's say you wanted to buy something that costs $40,000. You don't have $40,000 right now, so you go to the bank and ask to borrow $40,000 and tell the bank that you're going to pay them back in 4 years. And they say, okay, we'll do that, but we're going to charge you an annual interest rate of 4.8% every year. Now, this is similar to what happens whenever you go to buy a car. You need to buy a car, you don't have that much money at one time, so you try to finance an amount, and then the banker or the finance person comes back and gives you, okay, well, how much this is going to cost a month. To calculate a monthly payment, here is the formula. It looks kind of crazy, but what's going to happen with these problems is you just have to figure out what the numbers are that go into the formula, then type the whole formula into Desmos. So A is your monthly amount, P is the principal or the loan amount that you're going to take out, N is the number of months, I is the interest rate, the monthly interest rate. So you're usually in the problem, you're given a yearly interest rate, you're going to need to divide that by 12 to calculate I. And then K is a number you're not going to substitute in. So you just need to know what you're going to solve for A, so you need to know P, N, and I. You got to know three things. So here, I am going to take out a loan of $40,000. So the P here is 40,000. Four years is how many months? Because I need to know the number of months. So N would be 4 times 12, which is 48. So N is 48. My interest rate is 4.8. That's yearly. So to get I need to take 4.8% and divide it by 12 because there are 12 months in a year. So when I take 4.8 divided by 12, I get 0.4. But whenever we put it into a formula, you need to change it to a decimal. So divide 0.4 by 100, 0.004. So my formula to calculate my monthly payment is going to look like this. 40,000 over the sum from k equals 1 to 48 of 1 over 1 plus 0.004 raised to the k. And I'm going to go grab my Desmos calculator. I'm going to enter all of that in to calculate my monthly payment. So type in the word sum. Oh wait, I don't want to type in the word sum yet. I need a fraction first. 40,000 over, now I want a sum. And you can change this letter from an N to a K, just delete it and fix it. From K equals 1 to 48 of the fraction 1 over 1 plus 0.004. Go to the outside of this parentheses, and I'm going to raise that to the K. And then we are going to see what we get. 917.55, which is about, oh, I need my approximate symbol. So squiggly equals $917.55. So if I take out a loan from the bank, $40,000 at 4.8% a year, my monthly payment would be about $917.55. All right, that's all I have for you today. Have fun with this. Let me know if you have any questions.